Great minds make great beginnings, and that's really what we believe here in Stratford at the University of Waterloo. Who are we? We're a program that is absolutely rooted in the arts and believes hugely in bringing the human back into technology. We provide extensive exposure to the arts, and we provide enough technology to make our students a little dangerous, and then we provide business skills and exposure to business and corporations to make sure that they are beautifully integrable into the workforce. But that's not what I'm really here for. What I'm really here for is to introduce our keynote speaker today, Hilary Mason. Hilary Mason is a data scientist in residence at Excel Partners. And for those of you who know it, Excel Partners are the leading Silicon Valley venture capital firm. She was chief scientist at Bitly from 2009 to 2013. And for those of you who don't know, Bitly, of course, is the link shortening service that facilitates sharing across many social media platforms. While at Bitly, Hilary sifted through thousands and thousands of records of clicks to find patterns. That's a lot of data, and she'll tell you all about it. If people visit your website, she'll be able to tell you what other pages they're probably looking at. Hilary's also a member of NYC Resistor and Mayor Bloomberg's Technology and Innovation Advisory Council. She's on Fast Company's 100 Most Creative People in Business for 2013. Please give a warm welcome to Hilary Mason.
So hello, I'm Hilary, and thank you for having me here. I'm pretty excited to visit. It's my first time in Stratford. And I also believe that putting the human in technology is important, and in fact, I want to use technology to go the other way and actually give us superpowers as human beings. And so that is the topic of this talk today. I also want to say hello to everyone who's watching remotely. I know it's never as much fun to watch remotely as it is to actually be here, but if you have a question and you're remote, feel free to send it to me on Twitter. I'm at @hmason, and I don't know when I will answer them, but maybe on the way to the plane I will answer them. But I always get back to people and I always answer my email, so feel free to get in touch. All right, so technology is working. My talk today is really to talk about why data is important and why data is interesting. And I know that you've all been listening to the same theme all morning, so hopefully mine will at least have cuter pictures of kittens in it. But I do think we are at a fundamentally interesting point with respect to the application of data and technology, not just to our electronics products and the websites we make, but to our lives and our government policy. And I'm a huge fan of, one, hackathons, not because you're going to build some great business and get rich, but because a hackathon is an opportunity to take some time, hang out with some fun people, eat a lot of pizza, burritos, drink a lot of coffee, and make something awesome. Like, don't worry about, and this may go counter to any instructions you're going to receive later, so you might have to disregard this, but really don't worry about how much money you're gonna make or even whether you're gonna win a prize or not. Just make something that you think kicks ass, and you will have won at the hackathon. My most ridiculous hack at a hackathon was actually a cake, a frosted cake with LEDs in it that could tell you whether someone was happy or sad, and the appropriate LED smiley face would light up. We were a little drunk when we came up with that idea. It worked out beautifully and was a lot of fun. So I highly recommend embracing your creativity and build something that's cool. All right, but this talk is about data. Before I talk about data, I want to set the stage. And it's 2014. That seems a little amazing. We live in the future. This is the world we live in, so I know this might be hard to read, and I'm not sure if those of you on the remote view can even read it at all. How many people here are familiar with Reddit? All right, maybe a third of the audience here. For those who are not familiar, Reddit is the armpit of the internet. It is where people go on social media to be free, that is unconstrained by things like politeness and courtesy and kindness. But it results in some things that are really creative, sort of bubbling up out of that chaos. And this is a question that I really love. So somebody posted this question and they asked, if someone from the 1950s suddenly appeared today, what would be the most difficult thing to explain to them? And here's the answer. I possess a device in my pocket that is capable of accessing the entirety of information known to man. I use it to look at pictures of cats and get in arguments with strangers. Okay? This is the internet. This is where technology has brought us in 2014. This is another photo I love because this is President Obama on the campaign trail, and what's interesting about this photo is that there are thousands of people in the audience. Every single one of them is holding a device of some kind. Every single one of them is documenting their experience, is creating data, is gathering data, and their own data about this experience they're all having socially together. And this tells us that humanity stays the same, but technology changes quickly. And it's impossible to talk about the arc of technical change from one point in time. So I really want to go back to the first data engineering problem I could find. And it's this. This is the US in 1880. You'll forgive me, I'm American, so I'm going to talk about the US a bit. The US Census in 1880 took 7 years to complete. The population in the United States roughly doubled between 1880 and 1890. So they couldn't use the same techniques they used in 1880 and expect to actually finish the census within 10 years. That is a big data problem, at least on 1880 scale. And there were a bunch of reasons why a technical solution became possible at that time. Factory work had just started picking up. It had become cheap to build certain kinds of machinery. And this guy, his name's Herman Hollerith. He's from New York. I'm also from New York. So we have that in common. Also, if you get rid of the ridiculous mustache, he sort of looks like a bunch of the people in this room. He just sort of looks like a nerd. Maybe that'll come back into style. I'm sure he was really cool in 1880. So he lived in New York, and he came up with this idea that he wrote a patent for. And it is for a machine to count the US Census. It was a very specific machine. There was no notion at this time of generalized computing devices or even of data as data itself. And he actually, you can look up the patent online. It's got some really cool sketches of what the machine would look like. He had the idea because if you traveled by train at that time, when you paid your fare, they would check off a ticket saying the demographics and the fee that was paid by this person. So they'd be like, a woman with a hat in the seat paid this much. And he was like, okay, why can't we do that for the whole country, for the census? And this is the machine he built. It's a little hard to see, but you have the punch cards on one side, the counting machine, and then that's where all the tallies would come up. He started a company called the Tabulating Machine Company. So Vint Cerf is one of my favorite computer scientists, and he said once that if computer scientists had named Kentucky Fried Chicken, it would be called Hot Dead Bird. Okay? This company merged with another company and another company, and it eventually became a company we know today as IBM. So they fixed their branding problem. Computer scientists should not name things. At least I shouldn't. Here's one of the computers, one of the women who would actually go out into the towns and count the people in the town with these punch cards. This is what they looked like. This is the decoder ring for them, and I spent a lovely evening actually figuring out how to decipher these. Happy to share some source code if anyone wants to play around. It is a deep rabbit hole. But what I figured out also is that you cannot even fit one tweet worth of data on here, even if you write your tweet in 7-bit ASCII, not 8-bit ASCII. So there's really not a lot of data on a lot of physical space. And for one reason, the punch cards were actually the exact size of 1887 US currency. So you might ask why. This is what 1887 US currency looked like, by the way. It's way more badass than current US currency. And it was about the size of a Canadian $5 bill. I love the kids playing hockey. So this is what the size of the currency was. His punch cards were this size because he got a bunch of surplus Treasury Department boxes to put his cards in and send them off around the country, which tells us there's always a reason why things are the way they are. So for the older folks in the room, this is on SuperUser, which is a website for system administrators to ask questions, and a presumably young system administrator recently asked this question, which is in Windows, why do we have A and B drives? Okay, old people are laughing. Young people, you should ask them later. But I'll tell you, there's always a good reason why things are the way they are. And if you look at history, you can usually figure out what it was. That's not to say you shouldn't rethink them now, but there's always a reason. So back to the 1890 census, they had these lovely counting machines. They sent mostly ladies out all around the country to count how many people there were. They nailed it. So if we wanted to make a grand philosophical statement about what punch cards did for us, we could say they made the world computable, and it was the first time we were actually able to count ourselves. So no presentation on the topic of data is complete without graphs that go up and to the right. I like this one because it also goes down and to the right. But the point is that data is increasing, we could say at an exponential rate, and we'd better figure out what the heck we want to do with it. I like this one because it's from the Washington Post, so at least it has some prestige along with it. I could show you a ton of these graphs, but the graph is not the point, rather to say we are at an interesting point in the evolution of this technology, and it's worth being mindful of where we came from when we think about where we want to go. So, all right, back to today, 2014. What is the most remarkable thing about this picture? This, for those who cannot see the image clearly, is Google Maps. It has the traffic layer turned on. It is Boston. Okay, the most remarkable thing to me about this picture is that it is boring, right? Google Maps is one of the most amazing data products in the world. We get real-time traffic information in a format that we instantly visually understand for anywhere in the world, and we take it for granted. It's an amazing data product. So I'm going to spend a little bit of time telling you some things that I think are really interesting that we have recently learned from data exhaust, from data that's been collected generally for other purposes. Talk a bit about some products that I think are doing a great job of taking that data and making it useful and therefore boring. And then end with some grand philosophical statements about the future of data science. So big data, and we have to address the big data question, how big is it? It is our knowledge about the world. I've gotten in many conversations with people about how big data is or how big it has to be big. And if you've ever read the OkCupid blog, which if you haven't, OkCupid is a dating website. Their blog does a fantastic job of telling stories about human nature through the data that people express when they're looking for a date. So it's hilarious because it involves people trying to get laid. And I won't put it up on screen because it's not terribly appropriate, but you should look that up because they're telling beautiful data stories off of what we would not consider to be big data. The majority of that work was done by a fantastically talented team in Excel. So maybe big data is data that's too big to fit in Microsoft Excel, and that's fair. For engineers, we tend to use a more technical definition. We say, well, big data is data you can't analyze on one computer anymore. So you need specialized infrastructure to do that analysis. And that is fine, except as engineers, we are quite pedantic, and we might say, okay, well, what can one computer do? What one computer can do today is quite a bit more advanced than what one computer could do 2 years ago or 5 years ago. So how many computers do I really need before it's big? And then you end up, you're like 4 whiskeys in and you haven't accomplished anything at all. So I prefer a different definition of big data, and that is big data is data made useful. In the case of deploying specialized infrastructure to count things, like having a Hadoop cluster, it means we can ask a question of the data and get the answer back before we forgot why we asked the question in the first place. It's a human problem. Big data is a technical solution to a human problem, and that is our inability to pay attention to things for very long. We're really just little data monkeys. All right, so at the same time, I've addressed big data. That's a term that a lot of people use, but what about data science? Data scientist is a new profession. You can actually get a degree in it as of this year. There are several universities offering master's programs or undergraduate specializations or online degrees. Data science is one where I think it does merit a new term, not because we are doing anything we haven't done before, but because we are combining skills in one professional that have not been combined in one job before. So those skills are doing math. That is going to the whiteboard or the chalkboard, depending on your preference, and actually thinking up a way to symbolically represent something, doing statistics, building models, fun stuff, right? Writing code, that is, there is data out there. How do you get it? How do you process it? If somebody gives you a key to a database, what do you do? And then once you've got that data, how do you take the beautiful model you dreamed up in the first step and apply it to that data and iterate? The technical tools for doing that job. Some folks, though I would call them data engineers, also build scalable infrastructure for storing and processing data. That is a bit of a different specialty. Not every data scientist does it, though it is a heck of a lot of fun. And then data scientists ask questions. So there is no greater insult for a data scientist than to say you have an elegant solution to an irrelevant problem. You have to ask the right questions, and this often means that a data scientist who is working in service of a business has to know what the priorities of the business are. They have to be able to solve problems with data that are actually relevant to the decisions people have to make. And if you're building products, you have to know what you need to understand, so you have to know what you don't know. And there are lots of reasons this is happening today in 2014 in the way it is. For one thing, we have data. It is now more affordable to keep your data than it is to throw it away. That is a very simple change that has far-reaching implications. We have cheap CPUs, so you can actually process the data once you have it. And we have algorithms. We know what to do with it when we have it, or we're getting pretty good at it. There's still a lot of work to be done there, but we're better than we used to be. So back to this question, what can we learn from a bunch of people or monkeys, each carrying devices? There's even a laptop in the middle there, around the world with them and documenting, communicating, mediating their lives through technology. We can learn a lot. We are studying human behavior at the scale at which human behavior actually happens. And we're not just sampling it. We're not saying like we think undergraduate freshman men are representative of all of humanity because they're the people who will take $10 to take this psych test. No, we are actually counting the entire population. And we are assembling perhaps the greatest database of human gossip ever collected. So I worked for 4.5 years on social media data, and some of the things I'm going to talk about come from that experience. We're understanding a lot about how we socialize as people. There's a principle in social science called homophily that we see borne out in our social data quite readily, and it's best demonstrated by a few examples. So this is a tweet. It is a screenshot of a tweet of a young black woman saying any white person on Twitter is a spam account. This was totally true for her. It is not true for us. So homophily means like groups with like, meaning that you are more likely to use technology in the same way your close friends and associates use technology. That means that you think everyone else is like you because everyone around you is like you, but it's not true. And this is also, I think, why parents tend to think their kids are like technical geniuses when they're trying to swipe the TV. It's because their kids use technology in a different way than they do. I'm sorry to say it doesn't mean they're brilliant. It just means they have different habits and expectations. And here's another example I love of a person who held a Lego goldfish funeral for his goldfish with all of his Lego people in attendance. And you probably can't read it because the screen's rather light, but the last comment is, "May God rest his soul," which is a level of punniness not attained in most of Facebook. So if you want to play with this diving into random content on social media, I made a website that just sits on Twitter's public fire hose. I didn't do it at a hackathon, but it's exactly the kind of project you could do at a hackathon, where it just shows you one random tweet from the world, from someone somewhere, and whatever they're saying, it's public. It's the code's on my GitHub page as well. And it gives you a very interesting perspective on how other people use social media. They don't use it the way you do or I do or anyone you know does. And this is an example of the kind of thing you will see if you're lucky enough to get one in English or French or a language you speak. Yeah, I don't know what's going on there. So a lot of times people ask questions about influence, like can we use social media to influence people, or marketers ask me that. Other people ask, like, can we understand who's influential? The best work on this actually comes from a guy named Sinan Aral at MIT, and I'll let you look up the rest of his work, but this is a graph he made that I love. It shows your susceptibility to influence correlated to your relationship status on Facebook. Excuse me, you can see that single people, not that influenceable. If you're in a relationship, you are more influenced. If you're engaged, you're very influenced. If you're married, you're very hard to influence. If it's complicated, it's complicated, right? We're starting to see the way people construct their identities socially. So this is one I love because this is a 12-year-old boy trying to pick his screen name for a video game. And at 12 years old, he's keenly aware of the social consequences of this choice. So he's making a list, and he's like, Zelda Conquer is cool, or like Punka Funk is cool, but he's like, note to self, do not be bread boy. Right? He felt so strongly about this, he wrote it down for his poor parent to find and put on the internet so the rest of us can appreciate it. The way we construct our identities is keenly socially aware, and we're only starting to understand that. So at Bitly, one of the projects we did was look at how people behaved versus how they said they wanted to behave. So we looked at what they shared versus what they consumed across social media. And, we tried very hard to make a graph or something that actually looked professional and scientific that could represent this, and it failed miserably. Nothing did as well as the kitten and the chicken outfit. So what people share is things. Sorry, my little button's not working. Okay. Things that make them look good, right? So they share news stories. They share photos that sort of make their lives look exciting. They share things they feel very strongly about. So things that are politically provocative, whatever their politics happen to be, they will share. And the same people who shared those things were clicking on these things. This is celebrity gossip. The more babies involved, the better. Sports get a ton of attention, not that many people publicly excited except for really big events. Vaguely dirty jokes that aren't even that funny. And then things that fall into this category of, stuff you would read but not want your mom to know you're reading, basically. It is a headline on a respectable website, but something that many, many people clicked on and very few people shared publicly. And I think you can see why, right? So people present these cultured identities. They sort of want to seem way more awesome, but they behave in a way that is not necessarily consistent with that. And we're still at the very beginning of understanding the interplay of identity and the data we collect and generate. And so when I talk to people who are concerned with marketing, I always tell them to be very careful with explicit signals. That is, it doesn't matter how many likes you get. If you get the right people to read your stuff, it's much more important. There's a lot of work to be done there. We can look at how geography or the dimension of space affects the way we think about information. This is one of my favorite examples. I love pizza. I'm from New York and I love pizza. And this is what people in New York read about pizza. For those of you who are not from New York, if you visit New York, it should cost no more than $2. It's all New York pizza, and it's all good, and you don't eat it with a knife and fork. You roll it up in your hands and just stuff it in your mouth, and you can do it walking down the street. That's totally cool. This is how New Yorkers think about it. This is what people in San Francisco, California think about their pizza. Yeah, artichoke, I mean, come on. And this is what people in Rome, Italy think about their pizza. I don't speak Italian, but it looks pretty yummy to me. But you can see that the whole world unites around a concept like pizza, and yet geographically we consume that data in very different ways. Another project we did with Forbes in the United States was looking at the influence of national media by state, seeing things that were not a surprise at all, like Fox News is disproportionately influential in Texas, and NPR in Oregon, it's public news, and The Onion in Wisconsin, we love Wisconsin, right? New York Times in New York, not a surprise. The team actually went and made a real-time version of this, so you can go look for Bitly real-time media map, and you can see as people click links, dots are appearing on this map. There's some pretty cool in-memory database technology behind this as well, which is open source. And on Bitly's GitHub page, we have two databases. One is called Forget Table or Forgettable, and the other is called Count Me Maybe. And I told you computer scientists should not be allowed to name things. Time is an equally important dimension, so you can monitor what people are paying attention to at any given moment. And one of our research goals at Bitly was really to understand that. This is from last week during the Olympics. Huge spike of attention on Bodie Miller, and it turned out it was because he was really emotional and we all felt bad for him. The way we use language changes based on our context as well. So this is a website called Giphy. If I tell you nothing else interesting today, go look this up. It's Giphy.com. It is an animated GIF search engine. When you put your mouse over things, they actually animate. It's great. This is a graph made by Gilad Lotan, who's the chief scientist at BetaWorks, sort of a sister company to Bitly, and he was looking at the way people use language to describe these animated GIFs, and he found that people use funny and LOL in completely different ways, even though they might have naively seemed the same. LOL, for the older people in the room, again, is laughing out loud, and funny just means funny. So funny means haha funny, like we're laughing, this is cute. LOL means WTF, it's something weird, right? The world of animated GIFs revealed. So I love these toy examples because they're silly, they're exciting, but they actually demonstrate something interesting about language as well. Another project to take a look at is called the Hedanometer. It's from some folks at the University of Vermont. They actually use Twitter data to robustly and mathematically model the happiness of the world. And it's cool, you can mouse over any given day and see which words made people happier or not happy. We got really happy for a while back in 2008, and then I think people started getting less happy when celebrities discovered social media. But we seem to be evening out again. You can blame Justin Bieber for that too. Now this quote, "Computation is the new handmaid of science," meaning that computation has taken the place of mathematics as the partner technology to scientific thinking. It comes from this article, which was published in Communications of the ACM, which is the Computer Science Professional Organization, a couple months ago. This is an amazing paper. So this is a paper by linguists who are using machine learning technologies to take what they know about our modern languages and the mutation rates of modern language, and to, from these things, use machine learning to derive the language, the ancestor language. I found it fascinating because the topic itself is really interesting, but also because this is a case of computation, machine learning being used to augment the professional scientists who are linguists. So it's not replacing them with a tiny shell script. It is building a system that helps them apply their domain knowledge to a series of problems that they could not otherwise address. They were boosted beyond their mere human capacity to do some pretty amazing work. Okay, so that's a lot of philosophy. Let's talk about some things people have actually built. And I'm not going to talk about ad targeting, financial modeling, or things that we are all pretty familiar with and that are already boring. I want to talk about some stuff that's actually cool. This is one of my favorite apps. It's called Dark Sky. They take US government public data. They take your GPS location off your phone, and they will tell you a real-time weather forecast for where you are standing, meaning they will notify you when it's about to rain or snow where you happen to be. Now, when I tell people in California about this, they're like, so what? But I'm from the East Coast, and so are most of you, so you can appreciate it. The same team has this website called forecast.io, so if you're not on an iPhone, there's still a website you can use, and it gives you up to the minute rain and snow forecasts. It is pretty great, but it's great because it is a product that is not possible without doing a huge amount of computation to understand a huge amount of data that is then rendered for you in a really simple, beautiful UI that you can instantly understand and actually make a decision that makes your life better. Here's another project worth mentioning, and it doesn't have any pretty graphics or nice graph. This was documented in a talk by Lauren Talbot at Data Gotham. In New York, she worked for Mayor Bloomberg's Office of Analytics, where they took the city's data, New York City, and tried to use it to improve the city. And one of the problems they addressed was ambulance response times. So they looked at a bunch of different things, like where do the ambulances sit when they're waiting for a call? And they found out, of course, they don't sit anywhere near where the optimal point would be in each precinct for them to sit. So they asked them, why are you sitting over there? And they said, well, that's where the 24-hour coffee and bathrooms are. So they said, okay, maybe you could sit by this 24-hour coffee and bathrooms. They also looked at the order in which the operators are asking questions to see if they can change the order of the questions to get the calls routed more effectively. And through a bunch of very simple data-based interventions, they actually reduced ambulance response times in New York by around a minute. They are saving lives just from looking at the data. They've done a bunch of other stuff too, but that one just blows me away. This is a screenshot from the Jawbone app. How many people here have some sort of wearable fitness device, all right, people in the back. Nobody in the front, apparently. I don't know what that says, actually. This sample size is too small. So these devices cost around $100 or $150, and they track your steps and sleep, and they are making our own health transparent to us. I know I've learned personally from mine that when I travel, I tend to sleep an hour less a night, and I tend to walk about 5,000 steps fewer a day. So when I get home, I'm gonna have to go to the gym to make up for sitting down in a plane all that time. But the amazing thing is in aggregate, so this is an infographic Jawbone released, and it's sort of hard to see, but they were able to show that for the people using this device to measure their sleep, we lost an average of 11 minutes of sleep during daylight savings time. So if you extrapolate that to the US population, that's 6,000 years of lost sleep over what some consider to be a silly, antiquated daylight savings time policy. So this is the first time when we're seeing both health data through a very cheap device at the scale of the population that could actually influence our policy decision. And again, it's collected because I want to know how well I'm sleeping, but in aggregate, it tells us something really interesting about our society. And my last example is a donut with bacon on top. This is, again, a good one to Google. There was a study showing that recipes that have bacon or cream cheese in them are more likely to get 1.5 more stars than other recipes. So if you want to create an award-winning recipe, just put bacon on top of it. The data shows it's true. All right. So we are really just at the beginning of what is possible with data, and most of the examples I selected to share today are ones that are emerging or in progress or still, not that widely known. There is huge opportunity in using data to make people's lives more interesting, to use data as a tool for understanding things about the world that we did not otherwise have a means to understand. There's also a huge amount of value there. I know I talk a lot about making things that are awesome rather than things that make money, but I've been lucky to make some of each. And when you take something that was intensely expensive, even just 5 years ago, and you make it as cheap as it is now, things become possible that weren't possible. So one example, I spoke at a conference for young teenagers who might want to be scientists when they grew up. And I gave a talk not that dissimilar from this one, maybe a little more technical. And this young woman came up to me after the talk and she said, "Can I tell you about my science fair project?" And I said, "Sure." And she said, "Well, I got my DNA sequenced and now I'm trying to correlate different traits in my DNA." And I was like, "Okay, how are you doing this?" And she said, "Well, I set it up on Elastic MapReduce. I'm using 100 machines and the DNA is actually not that long because she had one of the sequencings that only identifies SNPs, so it's about 10 megs of data." And I was like, "Okay, how are you even paying for this?" And she said, "Oh, my allowance." Now, she may have very generous parents, but allowances don't scale by orders of magnitude, right? So assuming she has a very generous allowance, there is a teenager doing really cool stuff on her allowance with data that is completely mind-blowing. So if you think about the resources you have access to in a university, or even a startup, you can do some amazing stuff without a big budget. So open data is also a source of better opportunities. So in New York, we've had a ton of open data sets. They have been the subject of a couple of hackathons and events. One of my favorite hacks was by a guy named Max who made an app where if you check in a restaurant on Foursquare and it got a bad health department rating, it will actually text you and tell you to leave. So unfortunately, the text will come like right as you're ordering, so it's really awkward. So there's a little bit of work to do there, but having that data in the city be open has allowed for some really interesting stuff. I taught a class at NYU, and one of my students there used open data about the number of people going through the toll booths to actually try to quantify the cost of Hurricane Sandy in terms of how many people did not come in to work for the following month. So some amazing work is possible with open data. And the thing about open data is that it has to be open. It has to get to as many people as possible. So if you are someone who could publish data, I know in the audience we mostly have people who will build things on data, but if you're on the other side and you're thinking, oh, maybe I shouldn't release this, release it anyway. And if you're thinking, like, oh, it's just an Excel spreadsheet, no one will care, well, somebody will make it useful, so please do that. All right, and my last slide is that I'm going to make the argument again that data and technology really do give us superpowers because they give us as people, as technologists, capabilities and knowledge we otherwise just never would have had. And with that, thank you very much. Build awesome stuff, and if you do want to get in touch, I'm very easy to find. So thank you.
Thank you so much, Hilary. Really appreciate all of your amazing little tips and stories. We love the stories. So now what we're going to do is to open up this to some discussion and some dialogue. And as Hilary has said already today, this is her favorite part. So questions. So do we have any questions from the audience? Oh, come on. Well, maybe while people are thinking, I've worked all my life in technology, and I recognize you as a person that really has a very strong right brain and a very strong left brain. That's not always the case, and often right brain people. And could you give us any hints as to how, for example, someone who has an arts background could effectively interact with someone who is much more of a left brain person? And I think there may be a story in here.
Sure. I think it requires both. To build something interesting requires the creativity to realize it. Now, people who are technical and software engineers tend to get caught in thinking about what, as a software engineer, I'll be like, oh, no, we're not doing that because that's, really complicated or it's not possible. So the best thing for people on the creative side to do is to be creative and to have tons of bad ideas. And in fact, in managing a team of quantitative data scientists, my role as manager became like queen of bad ideas. So it was to say, okay, we've got this data, can we figure this thing out? And have people say, no, never, but we could do this other thing that is more possible and within our reach. In my experience, the best projects I've seen, especially out of hackathons, come from collaborations where you have somebody with the technical skill to build things quickly, not necessarily well. That's different from software engineering, it's hacking. And you have somebody who is, a little bit crazy, who has some ideas that somebody else already hasn't thought of, who is willing to push the technical side a little further. And sometimes you have that in the same brain, and sometimes you get a team of people together. And I also talk a lot to people who are trying to build a team. And the advice I would give there is think of your weakest area and find someone who's really strong in that. And then think of the two of you together in your weakest area as a team and find someone to add to your team who brings something you don't have already. And so as you grow, you're always adding in a new way of thinking and new capabilities. Awesome. Thanks so much. All right, somebody must have a question. We have one.
Where's the question? All right. I could have counted on you, Karen.
I knew it.
Hi, Hilary. Karen Shulman-Dupuis from the Mars Discovery District in Toronto. Can you give us some insights into how Excel and perhaps the VC industry itself is looking at big data and what you're trying to glean from that?
As soon as she gets the mic back.
Yeah, of course. No worries. Thank you.
We run a very efficient organization here, one mic.
Well, you should be wearing the step counting band today. Oh, she has one. So the question was, how is the VC community at large and Excel specifically thinking about big data? And I should say right off the top, I'm not an investor. I'm a technologist, so I hang out with the investors. And I generally do a few different things with them, but I'm not the one making the money decisions. So don't pitch me your startup. Pitch me your cool tech, and I can maybe help you with that. But broadly, so I met the Excel partners actually because in 2010 they started their big data fund, the first fund, which was a $100 million fund dedicated to big data companies. But what's interesting now is that the definition of a big data company is changing. So in 2010, which was only 4 years ago, most of those companies were infrastructure technologies. They were databases that let us, count things more effectively, whether they're bigger things or things in real time. Or work on streams of data rather than large static data sets or whatever it happened to be that was sort of building out that computation infrastructure layer. And then we saw a set of companies that are really around making data analysis accessible. This is something I'm still pretty excited about, but there are a lot of people working on it. So when you think about it, Microsoft Excel is the biggest programming language in the world. And you cannot be a business professional today and not be familiar with Microsoft Excel. And we want to take the same capability for big data to people. And I know Microsoft is in fact trying to do that with future versions of Excel, but they're going to have a lot of competitors, including companies like Tableau and then a bunch of small companies as well, that are trying to bring big data analytics capabilities to people who don't program. There's another company I really like in that space called IASD. Excel is not an investor there. I just happen to admire the product and the team where they try to boost the capability of domain experts, so folks in the pharmaceutical industry doing chemical research, medical research, with visualization tools. So it's helping experts not need programmers to do their jobs, which is pretty cool. Everyone's looking up, so I got nervous. There's like a laugh now sign or something. But I do think it's sort of an open question as to what will happen after that. So we've got our infrastructure, we've got the tools to use it. What do we do with that? And we're starting to see a need for companies to understand how they use the data they have to make better business decisions, like corporate metrics. That is a huge open problem. I don't actually think that's a problem to be solved by a product. That's a problem to be solved by companies hiring chief data officers and actually educating their leadership teams on how to use data well, because it's easy not to use it well, and hiring good analysts. And then we're also seeing more of these data products, so products that could not be built without the intelligence gained from a very large data set, but the product itself is almost adjacent to the data analysis, sort of like the weather app, or anything built on GPS, right? So that's what I'm excited about.
Other questions? I know there's one lurking out there somewhere. I'm going to come find you. Beth. Oh, there's a real person with a question.
What do you think the state of big data will look like in 5 years? Like, what do you think your daily life will look like in 5 years? Yeah, I think just for all of us in our daily lives, like you're already wearing the fitness, what do you think will happen in 5 years once we keep using this data?
I'm coming. This is really cool. I'm going to shine.
All right, so I actually thank you for asking this question because it's giving me the opportunity to have some of those crazy bad ideas. I think what we've seen so far is that human nature is consistent as technology changes around us, and we've certainly seen that reflected in the data we look at. And even though we carry phones, we still, care about the same things. We're still people. That said, I think in 5 years we will see capabilities in computers that we never imagined machines could have, and capabilities that edge on what we would have previously or even now consider to be the human realm of creativity. Of language. We will see algorithms that write English narrative better than our kids do. And I think it's going to be really exciting. That said, I don't think society will change all that much.
I'm the one down here.
Thanks. That was awesome information that you provided. My name is Greg. I'm from the Waterloo campus. I'm in the English department. My question is, like for me, I don't have that technical experience. Is there like a source that you could advise me on that I could use? Something to get us started.
We have an awesome master's program here. Oh, good. I should, no, okay. Tell them to get another master's.
So you can actually go online to sites like Khan Academy, where there's a really great intro to computer science curriculum, or a site called Code Academy, which is an online interactive tutorial that'll walk you through the basics of programming. There really is no good reason not to become at least a little bit familiar with these tools. And programming is much easier today than it was even 10 years ago. Building a web application is, it's possible to learn how to do that in a month of study, which is really amazing. Also, these tools are abstract and you just sort of say, like, make a form here and it happens. As a developer, that's great. This is not to say you're gonna, after a month, be a software engineer, but you will at least have the technical fluency to have an idea and make a working prototype of it. And that's where you want to get to, because that's the point where if your idea is really good and people are excited about it, you'll pick up teammates and it'll grow. But yeah, things like Code Academy, the Khan Academy, some of the Coursera courses, and even if you've had like an intro to computer science, you want to learn more about machine learning, there are courses you can take online that are pretty effective. And there's a great community of people online who are very supportive of people who are learning new things. So if you post to Twitter, hey, I tried to make this thing and it only half worked, you'll find those people too. And it really does help when you're learning something new to find that community. So in New York, I'm a member of a hackerspace or makerspace called NYC Resistor, and I know there are several of those types of things around here as well. So find a good room full of people who are also trying to learn something and you'll have a good time.
That's terrific. One last question. Yes.
You were mentioning the difference between somewhat older people and younger people and how they perceive the use of information. There's also the people that are very well educated and supported with facilities and parts of the country which are not. And we're doing a lot of work on data management in the Arctic, for example, where there's very poor communications, and yet because the groups are so distant apart, they use Facebook a lot. So they really rely on that for their sense of community. However, they're still going to be lagging behind the rest of the world unless some certain things are done. And I'm just wondering how you perceive this cultural distinction evolving over time, not only in the Arctic, but areas in Africa, in other remote areas that have their own distinct cultures.
You're going to have to now solve wicked problems.
Yeah, so this is something where I suspect you have a much deeper knowledge than I do, though we've seen things on both sides. So having Wikipedia has, it's been shown to actually reduce the amount of online content in non-major languages, which is not a good thing for preservation of culture. On the other hand, we have almost all of human knowledge in a format where almost everyone can get to it cheaply. So I think it is a very complex and nuanced question. And when you look at the way people use technology outside of our modern infrastructure environment, you find some really surprising things. And I'm thinking right now of work done by the UN Global Pulse, where they were able to look at prepaid phones in the developing world, and they found that in communities where people went from putting, say, $20 on their phone a month, but they started putting $5 on their phone every week, even though it was the same amount of money, the increments they used could actually indicate economic distress long before any signs of it had reached the traditional metrics. So I think there actually is a lot of opportunity to use data from those communities to help those communities more effectively and to measure the effectiveness of the interventions that are already happening. But I certainly would agree that, or I'm not even sure if you said that, I think that we need to be very thoughtful about the effect that these technologies have on culture and to be mindful of the fact that most of the great social platforms are for-profit companies that are going to make decisions for their profit, not to protect the privacy or interests of the community members. and that we need to have a large cultural conversation about that.
Thank you, Hilary. You know, I feel so privileged because I've had almost 24 hours of Hilary. I almost feel like Hilary. No, not at all. Thank you so very much, Hilary. It's just been a pleasure. Before you disappear, we have just a very small little gift for you. So thank you so much for coming and bringing us such important messages from your world and from New York as well. And we would encourage you to come up and visit with us at any time, and we hope to have you back again very shortly.
Well, thank you.
Thank you so much. Thank you, everyone.